Okay, welcome back, Physics 30s, to our next lesson in Chapter 4. This is 4.6, and today we're going to be looking at lens diagrams. Okay, so today we're going to look at how to draw ray diagrams for a lens. Now, we saw in the previous lessons that when light passes into a different transparent medium, such as glass or water, then it's going to change its velocity, and we looked at the refraction of passing into different mediums. So now we know that as light comes into a piece of glass, if it hits at an angle, that refracted angle inside of the glass will be different. And also when exiting the glass, the angle going into the air will also be affected by refraction. So now we're going to look at curved glass or lenses that are going to refract light in a way that will magnify an image. So we're going to look at two types of lenses. The first type is a convex lens where the middle or the waist is going to be thicker than the top and bottom. So that means from here to here is going to be thicker than we have down here. Now this may be the typical convex lens that comes to mind, but you can also just have half of it, which are these ones here, because it's still going to be thicker at the middle than it is at the top and the bottom. So they're all going to have a similar effect on light, and let's see what that effect is. If we draw some rays coming in and hitting this lens, I would draw the normal line to look at how it's going to refract. So I'm going to zoom in here, and hopefully you can see these normal lines drawn perpendicular to the lens. Because it's going to be slowing down in the glass, it should bend towards the normal. So I get a line there bending towards. That one was at 0 degrees, so it stays straight. And this one is going towards the normal as well. So we see that first bending, and now we're going to go from the glass into the air. So again, I'll draw those normal lines here perpendicular to the lens. And now I'm going to be going in the air and bending away from the normal. So I see this ray bend away, this one continue straight, and this one bend away. So we kind of get two bends involved there that cause it to converge to one point. Because it's bringing the light to one point, we call this a converging lens. Now we don't always draw the two bends, we often just draw one arrow to simplify this. So I can see in red here, drawing it to the middle of the lens, and then the rays coming together or converging. That's often the way we draw it, just to simplify that. Now because the front part of that lens caused converging, and the back part caused converging, we saw those two bends, if they are on their own, this front part would cause converging, and this back part would cause converging. So I have to look at those diagrams. We see the rays coming in, they would bend and converge towards a focal point. Same with the next lens, they would pass through, hit that curved side, and again curve to a focal point. In this experiment, we can see how the lens is going to bend these straight lines to focusing at one point on the left side, and even when we flip the lens around, they still focus to a focal point. So all three of these are types of converging lenses. The second type is the concave lens, which looks like this, where the waist is going to be thinner than the top and the bottom. This is the opposite to the lens we just looked at, and let's see how this is going to affect light. So we have our incoming rays, and just like the last one, I'm going to draw my normal lines right here. And now it's going to bend towards the normal, just as we saw before, but now these normal lines are in a different orientation. And when we bend towards the normal, now we're going to get rays looking like this. Again, staying straight in the middle. This happened for all of them because it's at 0 degrees to the normal. Now we look at when it goes to the air. Again, it's going to speed up or bend away from the normal. So let's put the normal lines. And again, they're in a different orientation due to the different curve. And now bending away from normal looks like this. Again, straight in the middle and bending away again on the other side. So now we have two bends, both of them being apart from each other or diverging rays. Similar to the other diagram, I'll just show this in red to simplify those two bends with drawing the red lines going to the center of the lens and then going away afterwards and diverging. Looking again at our experiment, we can see the light rays now diverging away from the concave lens. Now I didn't put it in a diagram, but again, if you just had the first half or the second half, this would cause diverging as well, and this would be types of diverging lenses. So now that we know converging and diverging lenses, let's do some ray diagrams to show exactly what these images will look like. So we're going to draw our diagrams like this, and you'll probably notice that this is the same on the left and right, and that's because the lens is symmetrical. Light could focus to this focal point on this side if it's shot from this direction, or if it was shot in this direction, it would focus on this focal point. You'll also notice that I have 2F marked on each side, And if you're familiar with mirror equations, this is where we had C, but again, that's not the center of a mirror like we had from before. This is just double the focal length on each side. So let's get into drawing these different ray diagrams. The first one we're going to start with is where we have the image beyond the focal point and we're looking at a converging lens. The first ray in our ray diagrams is going to begin parallel to the principal axis and drawn to the lens. And we're going to start at this top point of the arrow. So parallel to the principal axis to the lens. From there, we're going to go from the lens to the focal point of the lens on the other side like this, because the light is going to be passing through this lens. Our second ray is going to go from the focal point to the lens. That's going to look like this, where we go from the top of the arrow to the focal point and from the focal point to the lens. After the lens, it is going to leave it on the other side parallel to the principal axis. This shows the light rays converging, which is what we expect from a converging lens. And now we use where the two rays are going to converge to this point to draw the top part of the image, and we can see that it would be inverted. Now you can confirm this with a third ray. Ray 3 goes through the center of the lens and it's going to be unrefracted. That's because as we draw this line, it passes through the top part of this lens, which is going to be a surface like this, and then passes through the bottom, which is going to be a surface like that. So this is going to cancel out the refraction that occurs, and it's just going to be a straight line. And we can see it also intersects at the same point. Let's take a look at another diagram where I put the object at the focal point. Let's again start with the first ray parallel to the principal axis to the lens, and then to the focal point after the lens. Ray 2 is supposed to go to the focal point, but that would look like this, and there's no way I can get back to the lens from going straight down. So that one is not going to work for this diagram. So let's draw ray 3. Ray 3, reminder, is going to go through the center of the lens and be unrefracted, drawing it like that. Now what we notice here is that these rays are never going to come together. They are parallel to each other. And we also can't trace them back to coming from anywhere that they were together, because again, they're parallel. So in this case, we are going to get no image. And we saw this as well with mirrors when we had an object at the focal point. Our next diagram, continuing to move the object closer, we move it in front of the focal point, closer to the lens, and let's draw our rays here. First one, again, parallel to the principal axis, then going towards the focal point. Now our second ray is going to look a little bit different. You might think to draw it like it's going towards the focal point and then coming straight out parallel to the principal axis. But remember, this says from the focal point to the lens. This ray is not along a line from a focal point to the lens, although it would be afterwards. From a focal point to the lens is what we have to remember in our notes here. Another good check if this is correct is to say, does this make sense if the ray passed in the opposite direction, if we run it in reverse? And that's saying if it comes parallel to the principal axis, that it would diverge. And we know that doesn't make sense because this is a converging lens. So those are two good checks when you're drawing ray 2 for this diagram. So what ray 2 will look like is it's going to look like this, like it's coming from the focal point going towards the lens. And then it is going to refract parallel to the principal axis. This makes sense if we run it in reverse, that a parallel incoming ray like this would converge to the focal point. So that checks out. Next, we see that these rays don't collide or focus in on one point. So to figure out what the image is going to look like, we need to trace those back. Imagine that we are seeing the light ray on this side. Where would we trace the light from coming from? We would trace it back from coming from there, and we get it focusing at this point. This produces an image that is erect and magnified, and is similar to what you would be seeing through a magnifying glass. And we can always double check with that third ray going from the top through the center of the lens, and we see that intersects at the same point on the image as described here for ray 3. Lastly, let's look at a diverging lens. Now it will be pretty similar wherever we put the object, but let's put it right here for this example. So first one, parallel to principal axis, just like this, and then from the lens to the focal point. So you would think to draw a ray like this. However, that was for a converging lens. In this case, we shouldn't have parallel incoming rays going towards the focal point, we should have them going away. So I need to draw it going away like this. And how I know what angle to draw it at is so that I can trace it back like it's coming from the focal point. So it's important to check there. I have a diverging lens. My ray 1 should be diverging. Let's take a look at ray 2. On this one, I did change the wording that it's going to be on line from focal point to lens. So now we're going to have to be going towards the focal point on the other side of the lens. It's not going to work on this side because, well, first off, in this diagram, I don't actually touch the lens. But if you had a case where you had a focal point where it would, so for example, if I drew a ray like this and it was going through the focal point, we would have to draw that ray afterwards of coming out like this. Remember, parallel to the principal axis for the second part of ray 2. Now it's always good to check, does that make sense if it goes in reverse? So would it make sense if I went this direction into that lens that it would come to the focal point? It wouldn't. That would happen for a converging lens, but remember, this is diverging. So always good to run it in reverse and see if that makes sense. So how we draw ray 2 is that we're going to draw like we're going to the focal point on the other side, and then it is going to be parallel to the principal axis. This makes sense in reverse. It's coming in parallel and then it diverges. So again, always good to check if the reverse makes sense. Now to get our image, I'm going to trace back again. If this was my eye, seeing these light rays, trace them back, the yellow to there and the green to there, and I would get the image there being erect and being smaller. Always good to check with ray 3 going to the center of the lens and the principal axis, and we see that lines up as well with those rules. In this case, probably ray 1 and ray 3 actually being the easier lines, ray 2 being the more complicated. And that's it for this lesson. Hopefully that helped you to understand ray diagrams in lenses. Go give the practice questions a try, and I will see you in the next video.